Hi, in this video I'm looking at this problem here where we've got the half-life of carbon-14 is 5,730 years. A charcoal sample taken from a midden is analysed by scientists to currently contain 0.1 grams of carbon-14 and estimated to have originally contained 0.38 grams of carbon-14. We want to determine the age of the midden. Now when we see the term half-life, that means that over time, in this case this much time, half of the mass is gone, it disappears, it decays away. And that means that the rate that our mass is changing is actually proportional to the mass that we currently have, because we're going to lose half of what we have. So how much we lose is based on how much we have, but that changes over time. So let's set up our variables for this. So we're going to say that we're going to let M be the mass of carbon-14. And we'll say that T is going to be time in years. And so we'll set up a differential equation that the change in mass over time is going to be proportional to the mass. And so that means that we're going to say that dm dt is going to be some constant k times the mass. But because we're losing mass, it's going to be negative. So we're going to say that we're losing mass proportional to how much mass we've got. And so this gives us a differential equation. So now we can rearrange this so that we get all the m's on one side and all the t's on the other side. So that means I'm going to divide both sides by m to bring this m over here, and multiply both sides by dt to cancel out this one over here and bring it over here. So if I do that, it's going to give us dm divided by m is going to be negative k times dt. And now to solve the differential equation, now that we've got our variables isolated, we're going to integrate both sides. The integral of, well, basically 1 on m dm is going to be ln the natural log of m, and the integral of negative k with respect to t, well, k is just a constant, so it's just going to be negative k times t, but we're also going to have a constant plus c. And so now we want to get m on its own because we want to know something about the mass. So what we're going to do is we're going to raise both sides to the power of e, and that'll cancel out with this natural log here. So that'll leave us just m equals e to the negative kt plus c. And we can separate out these two powers because they're added. So we can have m equals e to the c multiplied by e to the negative kt. And so we can now write this e to the c as just a constant a, so we have m equals a e to the negative kt, and we'll just say that where a equals e to the c. So that way we're just clear where that constant a it come from. So now we've got an equation that links mass over time. We just have these two constants in our equation that we need to deal with. But thankfully, we're given two pieces of information. We're told that currently it has 0.1 grams and was estimated to originally have 0.38 grams. And we also have a third piece of information over here that we lose half every 5,730 years. We're going to start off with the original amount. So originally it contains 0.38 grams. So that means at time equals 0 at the start, our mass equals 0.38. So if we go to our equation, m equals a e to the negative kt, and put this information in, so we're going to have 0.38 equals a e to the negative k multiplied by t, which is 0. So now we've got e to the k times 0. The k times 0 is going to cancel out and become 0. E to the 0 is just 1, so we can ignore that. And that means that our a equals 0.38. So therefore we get more information about our function. We now have m equals a, which is 0.38. So we're going to have 0.38 e to the negative kt. So now we need to use another piece of information and work out k, our other constant. And what we're going to do is use the half-life is 5,730 years. So that means that when t equals 5,730 years, our mass has halved. So we've got half of our original, which was 0.38. So now we can go to our equation we've worked out here and put this information in. So we've got for our mass, that's going to be a half times 0.38 equals 0.38 e to the negative k times 5,730. So now we have a 0.38 on both sides of the equation, so we can divide by 0.38 and cancel those out. So we're left with a half is equal to e to the negative k times by 5,730. And we want to solve for k so that we know what our constant k is for this particular decay. So we're going to take the natural log of both sides, so that way we can cancel out that e. So we can take the natural log of the half, and that's going to be equal to negative k times 5,730. And now if we play around with our log laws, when we have a division, that means I've got the natural log of 1 minus the natural log of 2, equaling negative k times 5,730. And the natural log of 1, well, that's equal to 0. So we've got negative ln of 2 equals negative k outside of 5,730. And so now I can divide both sides by negative 5,730, and that'll give us k equals our negative ln of 2 divided by negative 5,730. And those negatives cancel out, so k is going to be the natural log of 2 over 5,730. So if we put that into our rule, which we have here, we're going to have mass equals a, which we worked out before, which is 0.38, times e to the negative k, and negative of k, but k is this ln of 2 over 5,730 times by t. So that is the rule that defines the mass at any point in time t. 0.38 times e to the negative ln of 2 on 5,730 times by t. Now we can answer our question. Currently, the midden contains 0.1 grams of carbon-14, and we want to determine the age of the midden. So that means that if our mass equals 0.1, we want to know what's time. So if we go to our rule that we just worked out, we're going to have 0.1 equals 0.38 e to the negative ln of 2 over 5,730 times by an unknown time t. And so we just want to solve this for t. So we'll divide both sides by 0.8, so we have 0.1 divided by 0.38 equals e to the negative ln of 2 over 5,730 times by t. We can take the natural log of both sides so that we can cancel out that e. So that means that we can have the natural log of 0.1 over 0.38, which is going to leave us with negative ln of 2 divided by 5,730, all multiplied by time t. And so now we can multiply by 5,730 and divide by the negative ln of 2, and that will give us t. So we're going to have negative 5,730 times by the natural log of 0.1 on 0.38, all divided by the natural log of 2. And so if we put all of that into our calculator, we get a time of 11,035.98 years. So that means the midden is approximately 11,036 years old. And so we're done. So if you have half-life, that means that the rate of change of mass is proportional to the amount that you have. And if you have anything that's proportional, that means that your rate of change is some constant times your mass, or whatever it is you have. If you are decreasing in value, you have a negative proportionality, so we have negative of our constant. We can rearrange to isolate our variables, integrate both sides, we can get a formula, and we can use different information given, whether it's initial conditions, information later, to find an overall equation. And then we can use that equation to find other pieces of information about our scenario.